I work in the field of polymer physical chemistry, and a physical chemist is a chemist who understands the relationship between molecular structure and function. So what we mainly work with are polymers that you can form into a shape, polymers that you can maybe dissolve and form into a small particle to deliver drugs, for example, or polymers that you might want to form into a film with particular properties like anti-fouling properties or antimicrobial properties. My colleague, Dr. Chonghui Fu, has designed a new class of polymers which have what we call stealth-like properties, so that when they're injected into the human body, they will not attract accumulation of proteins. And what this means is that when we attach our new polymer to a drug, it will circulate for a much longer time in the body and have a much greater chance of reaching the tissue target. So we've been working in the field of fluoropolymers for maybe 20 years. And one of the earliest research programs that we initiated was partly fluorinated MRI agents. So we're the world leaders in this field. Often diagnosis is difficult if you're trying to diagnose early stages of disease or very small lesions in the body. So we've developed these fluorinated molecules which you inject into the body, which locate at the site of disease, and we can very specifically image them using MRI. And probably the area with the greatest long-term impact will be the work on PFAS, because the technology that we developed is significantly better than anything that exists in the marketplace at the moment. Perfluorinated alkyl substances, or also known as PFAS, are used in the production of many of our common household goods. For example, our clothing, our shoes, our non-stick fry pans. Over the last few years, it's become apparent in a number of studies that there's a relationship between PFAS exposure and some health problems. We use our modified polymer, which selectively absorbs the PFAS from the water to clarify the water. We're developing processes which have industrial scalability, so we can make large devices for cleaning up large volumes of contaminated water. So a really strong theme is to connect to industry, to take our fundamental research, because we're very strong in fundamental research, and to put that into a real-world context. So to make it into a product, or at least partner with someone who can make a product. But probably I'm most excited about making a difference to our educational landscape, training the next generation of scientists, because we're all working towards a common goal of advancing society.